Here's a 3D printed model of the Cielo Centro Observatory design, which includes the exterior observation plaza. The model's pretty accurate at a scale of 50.8 to 1, which, in case you're thinking about that as a weird scale, means that 2 inches is equal to 1 millimeter. There's a couple of minor exceptions to that accuracy. The first is this red thread here, which is used in the model to open the sliding roll-off roof here. The other inaccuracy is that the real system will not have these vertical support bars here at the end of the rails, because the real system will use steel girders and beams, but in my 3D model, which is made out of PLA, the PLA plastic isn't stiff enough to hold the roof without sagging, so I've got these beams in. Other than that, the model is reasonably accurate. The main axis of the observatory is north to south, though various other angles, such as this angle on the portal here, will be pointing in a direction which is astronomically significant. I think this one is the direction of the sunset at solstice. East of the observatory, i.e. this side, this is the observation plaza. We put it on this side because our prevailing winds around here are from the southwest, so this is somewhat sheltered from those winds. This area here will be used for setting up telescopes, smaller telescopes, either the colleges or visitors' telescopes that they can then make observations from. And these 6 white pads here are vibration isolation pads, so that people, particularly astrophotographers, can set up and not have their images affected by vibrations from people walking around on the concrete slab here. The figures shown here, a seated figure and a standing figure, are with an 8-inch Dobsonian scope, just for scale. Over on the extreme east of the plaza, there is a raised platform which we'll use for both presentations and also can be used as an overspill observation area if we get a large number of visitors. Looking at the features of the observatory, here's the main entrance in here under another portal, and these portals are put in place primarily for daytime use, because we anticipate getting K-12 groups coming around to look, and so if they want to come and visit and the sun's out, they'll be sheltered somewhat from the sun. Looking at the rooms that we've got under this vestibule area here, let me move that. So you come in through the entrance to the portal under here, and this first room is nothing more than a light lock to prevent light from the outside here spilling into the observatory floor, which is under the main roof here. The second room here is a waiting room for people that want to wait to go into the observatory room, or possibly warm themselves if the observing conditions are quite cold. The next room is an IT room containing computer racks and various other instrumentation. And then at this end here is an ADA compliant bathroom. Notice that the doorway faces north, which means that any light spilling out from people using the bathroom will be pointed away from the observing area. The final pair of doors over on this side are doors to access the workshop, which I will show you next. Let me put the roof back on the vestibule area. So under this part of the roof, which of course won't be removable normally, we have a storage area for various telescopes. These are 8-inch Dobsonians here, 10-inch SCT. And then over on this side of the room is cabinetry and sinks for a workshop area for repairs and maintenance and so on and so forth. Let me put the roof back on there. There. So moving round to the south end of the building over here, we will have an overlook here with a number of infographic displays showing people things that are relevant to the astronomical status of objects and events that visitors can look at during the day and perhaps at night if we can light them appropriately. Now, I'm going to open the roof, and the main observation roof is here. As I say, this will, in the real system, be activated with motors and hidden cables, and this red thread here will be replaced by cables which will actually be hidden inside the channels here. So if I just open the roof, we open the roof to reveal the main observation floor. For scale, this observation floor is 30 feet wide by 45 feet long. And we show here 2 telescopes. Here's the main 36-inch Dobsonian, which we can move around a little bit. And at the other end is a 14-inch Schmidt-Cassegrain. Now, what's a little different about these is that both the Schmidt-Cassegrain and the Dobsonian can be used from a seated position. So if I point this in this direction, okay, so now a seated person, for example, somebody in a wheelchair, can now look in this white structure here, which is an optical relay system which moves the image from this upper point, which normally is 12 feet up in the air when it's pointing straight up, down to about just under 4 feet off the ground, 3'6", I think, so that somebody seated either in a wheelchair or in just a regular chair can observe without having to climb a ladder. That's got 2 advantages. First of all, it makes the thing fully ADA compatible or compliant, because the experience is same for somebody with limited mobility as somebody who is able-bodied and can just sit down. Secondly, it means that we don't need to mess around with a ladder. So normally if I move the telescope around, then if we were looking at the higher position up here, we'd have to move the ladder as well. Not only that, but we then need to wait for people to climb up and down the ladder. So we both make it more accessible to people, and also means that we can increase viewer throughput, because we don't need to move ladders or wait for them to climb up and down it. We've just done preliminary testing on our prototype of this system. Seems to work very well, and we're looking forward to implementing it on the big telescope. If we go to this telescope at the rear, that's a 14-inch SCT, and again that can be used from a seated position. This figure here is shown viewing through the telescope from a seated position, which of course could be somebody in a wheelchair. This one could also be viewed from a standing position, because it will be mounted on an adjustable height pier, which was donated to us by Gary Zientara, who does the Taos News astronomy blog. And so we can move the viewing height from about 28 inches, I think, to close to 50 inches. Anyway, so that's the that's the system that we're trying to implement at the Cielo Centro.